Okay, a vertical spring with a spring constant of 900 newtons per meter. So that's the K. Let me move this thing out of the way. Can I move this thing? Yeah, okay. Has been compressed 0.8 meters, so that's the X, okay? The vertical spring is then used to launch a 2 kilogram ball, so that's the mass, and then 68 joules of energy is dissipated due to air resistance, so that's the thermal. And then how high will the ball go? That's the H, okay? All right, so it's gonna be like some kind of spring, okay, here, all right? So that's the initial is compressed spring. Okay, and then after the spring has like uncompressed and the ball is up here now, okay? So I think we're just looking for this height here, okay? Or you can think of this as being like at the ground level. It doesn't really matter, right? Because remember, you can set your ground anywhere you want. So we're just looking for this height here that the ball will get to, okay? And then top of path, all right? Okay, let's see what we've got. Okay, so initially we're gonna say there's no EG, it's on the ground. Okay, wherever the spring is at, we're just gonna call the ground. It's not moving because it's sitting there on a compressed spring, and there's no thermal because there never is in the first position. All right, so we've only got EE. Okay, so the EE is 1/2 times 900 newtons per meter times 0.8 meters squared. Okay, and 0.5 times 900 times 0.8 times 0.8. Okay, so 288 joules. All right, so that's going to be the total then, because that's the only thing we've got. So we're going to put that over here, 288 joules. Okay, so let's see if we do like, oh, how can I do this? I want to do 100, 200, 300. I'm just going to make it a little bit higher. I'm just going to give a little extra space. So, oops, it's not even EG. Okay, so there's no EG, there's no EK, so EE is going to be the full 288. Okay. And then it launches it into the air. So it says 68 joules were lost to friction. So we'll add that. And then it's going to get to the top of the path. So there's definitely going to be EG. And if it's at the top of the path, it's not moving. So that's going to be 0. And then the spring has already sprung. So there's going to be none of that. Okay, so then if I do 100, 200, 300, my thermal is going to be 68, so something around here. And if the total is 288, okay, then that means the EK is going to have to be 220, right? Because if I do 288 is the total, 68 are wasted. So if I subtract those, I'm going to get 220. So that's the amount available that I have for the G. Let's just move this over. There we go, EG. Okay, sorry. All right, so then that's gonna equal EG equals MGH, okay? And I'm solving for H, all right? So I'm gonna divide MG in both places, EG over MG. Okay, so that's going to be 220 is what I have available. The mass was 2 kilograms times G, which is 10. Okay, so 220 divided by 20 is 11 meters tall. All right, there we go.